To implement the function c, I have to tell you about a new tool called a generator function, which is almost the same as a generator expression. We'll show you what it looks like. I'm going to define a function to iterate over the integers from some start to some end. And this is going to be just like range. Range is a great function, but sometimes it's annoying because you really don't want to go to one less than the end. You want to go up all the way to the end. So that's what ints is going to do. And I'm going to implement it as a generator function. I'm going to start off with an integer I that starts at the start number that you told me. And then while I is less than or equal to the end, I'm going to introduce a new type of statement here called yield. And I say yield I, and then I say I equals I plus 1. Now the yield is something new, and it makes this definition a generator function rather than a regular function. And what that means is what's going to happen is it's going to execute as soon as it sees this yield statement. It's going to generate that value I, but keep its place, and when it asks for the next, it will continue incrementing I and then continuing through the loop. And so when we call this function, if we say L equals the integers from 0 to 1,000,000, now L won't be a list right away, it'll be a generator. So now L is equal to this generator, some funny object, and then you call next of L to get the next object, and you keep on going through. And more commonly, instead of calling next explicitly, you'd say for I in L. And so generators obey this iteration protocol just like other types of sequences. And the great thing is we can yield from anywhere inside this function. So we can have very complicated logic here and then yield a partial result and then continue getting the next result right where we are. So this is a convenient feature for writing functions. And another great thing about generator functions is it allows us to deal with infinite sequences. Let's say we wanted to allow the possibility of an open-ended interval of integers, and we'll make end be an optional argument, which can be none. And the idea is that if we have a call, say ints starting at 0, but I don't give it an end, then that means all the non-negative integers, 0, 1, 2, 3, going on forever and never stopping. And the question for you is, how would you modify generator function in order to make it obey this idea of never stopping when end is equal to none? And you should be able to modify just this line here to make it obey this idea that it should keep on going forever when end is none.